Hey everybody, my name is obviously Adam. I am here to present on Greenfield network threat detection and practical strategies for operationalizing SuriCata. As we get into this, I figure we'll go over a quick introduction really quick. In my current role, closer, better, too loud, sorry. In my current role, I am a lead technical account manager with Corelight. That was really loud. And I'm also a part of our open source champion team, which is basically a group of open source enthusiasts. As a lead technical account manager, what we do is we work with a lot of customers who are purchasing services for Corelight, which includes SuriCata in it. So we get a lot of unique perspective that I think we'll get into here. Previous roles, I was actually a network security engineer before that for network threat detection components. And then I also architected, deployed, documented, configured, all of the above for SuriCata. And then I was also before that a security analyst. So I had basically the full run of the mill for experience in different areas dealing with SuriCata. Education, I have a background in information security and assurance with a BBA in that, and then I also completed the network forensics analyst, the GNFA certification through SANS and GIAC. So I guess as I was making this talk, I was trying to figure out why did I want to do this talk, and I think, as we said before, I have a unique perspective from the TAM role into various deployments. And then with that, we get exposure to a lot of different verticals, which if you're an engineer, you work for your company and that's it, but what about the other verticals? So we get that as well. And then with that, we get different levels of preparedness from the customers that we work with as well. I also felt like we should have some more operations-focused presentations in Greece. I think all the presentations are really good there. A lot of you guys do presentations that are well above my technical level, and it's really impressive. But I also feel like we needed more operations-focused stuff to sort of bridge the gap between engineering and operations teams. And then also I wanted to give a quick shout out. Like this was a lot of it was inspired by the SuriCata Extreme Performance Tuning articles 1 and 2, and then also we're going to have a third one, which I'm really looking forward to, and I think there's going to be a presentation on it later today. Lastly, I think really what I want to do is help Greenfield customers become more successful with their deployments because it's an awful lot to take in for people who don't know what they're looking at. I was in those shoes at one point in time. I kind of know how it feels. So presentation scope. Let's define what Greenfield means really quick. Basically what it means is brand new deployments. People have never touched SuriCata before. This is their first time into it. Maybe they had something in the past that wasn't SuriCata focused and they don't know the specifics behind SuriCata. Is it applicable to non-Greenfield deployments? Absolutely. I think there's a lot of this here that people kind of skip over as they're going through their first deployments and they can come back and sort of clean it up after the fact. And why I included the word practical in the title, it's actually quite important. When you talk about practical strategies, what you're really talking about is how much time do you have to spend on a platform like this to get it running properly. A lot of the engineers and operations folks these days, they're tasked with multiple platforms, not just SuriCata. So, where can we find, I guess, what's the word I'm looking for? Really high value decisions that you can make as you're deploying SuriCata. And then last point here, we're focused on passive deployments for the presentation. It's not to say that there aren't points that apply to active and inline deployments, just the focus of this one was passive. So being part of a success org, let's define what success is really quick. First off, success is based on goals. In Company A, their goals don't equal Company B. So Company A's success will not look like Company B's success. And even within a certain company, you'll have Team A and Team B. They also have different goals, so success means different things even within a singular company. Though I do think there are at least 3 basic deployment steps that you can call like the foundations of success, which would be tap and ingest, getting the information to the service. processing at the service, and then obviously the output of that into SIM platforms. And then beyond that, for operational adoption, the analysts need to have visibility over the output. It needs to be fulfilling their existing use cases or why they brought Suricata into the fold in the first place. And then on top of that, I feel like extending that or expanding into new use cases as they come into the light is also a key component. So I guess with that, what are the blockers that we commonly see to success? It kind of leads us into, like, if we know what the blockers are, then we know how to fix them. So I have grouped this up into 3 main categories, being architecture, management, and tuning. And as you can see here, I feel like architecture and management is sort of platform agnostic, though the details, can change. And there are details specific, obviously, to Suricata deployments here. And then you have tuning, which I feel like is very Suricata specific. So I think we'll actually spend the bulk of our time talking about tuning, which we had a couple great presentations about earlier today that I'm happy that we had because it kind of builds upon that. So getting into our first category, architecture, supporting platforms. This is sort of the basis. It's the foundation for how we either make a platform really successful or really unsuccessful. First and foremost, the taps and the spans you have in place throughout the network, they feed into a packet broker, and that's what goes into the platform. The best way to explain this is if you put garbage into it, you will get garbage out of it. That's to say, if you've ever deployed Suricata and you put a tap in place maybe in front of a perimeter firewall, and looked at what it does to Suricata, it's pretty debilitating. As far as whether you consider the platform for north-south, east-west traffic, or both, it really depends on what your goals are. I feel like if you're looking for lateral movement, you're probably going to want to feed east-west traffic. But if you're feeding it north-south traffic, then you may not actually see what you want to see. Capabilities and features within a packet broker platform. I think key to this is filtering, and we'll talk a little bit about that later on, but also hash space balancing, packet deduplication, that sort of thing. Those are all really critical components to, or really critical capabilities to a packet broker platform. Getting into SIM and XDR platforms, I see a lot of people run into licensing and ingest limits. So if they have, their SIM platform they've purchased and they have maybe 10 gigabytes worth of data they can feed into it per day. And they reach those limits quite quickly because it's not just Suricata going into it, it's multiple platforms. It's certainly a consideration, and knowing within an approximation of how much you're going to be feeding into your SIM platform is likely what you want to have in mind as you're planning for this. Capabilities and features, I'm pretty sure that all SIM platforms do some degree of dashboarding these days. But within that, you have certain components like drill downs and the correlations you can build into those platforms that would likely lend themselves to a more successful deployment with respect to being able to dashboard and do drill downs. As far as rule management platforms go, it's really simple. You need to have one. If you don't, then performing tuning is going to become quite difficult. With capabilities and features for a rule management platform, I think that doing context swapping, being able to go back and forth between enable, disable, modify, that sort of thing, that's somewhat important, maybe less critical for more straightforward deployments. Being able to identify flow bit requirements and automatically turn rules on that have a flow bit requirement behind it, as well as X bits and host bits are other really great examples of that. Which SuriCon update does do. Perfect. Talking about sustainability and resiliency, I think this maybe gets lost sometimes on people because they look at network traffic averages that they plan on feeding to Suricata, or maybe they're not even looking at it within the context of Suricata, they're just looking at it and they say, well, our average is, in this case, for this graph down here of a cloud sensor I have set up, is 1.8 megabits per second. Okay, that's great, but you're not gonna, if you work at averages and you don't work at maxes, you're going to begin to drop packets when you have spikes. And the highest that we could find on this graph was about 6.6 megabits per second. So if I were an engineer and I were architecting this, I might actually add 30% on top of that to make sure that I have a little bit of headroom on top of the max that I already have defined. That put us at about 8.6 megabits per second. Also with the deployment, you need to keep in mind that you're going to grow in network traffic as time goes on. So if I plan on having this particular platform in place before I replaced it in 3 years, then I need to start to plan 3 years out. And if I look at my traffic and determine that I grow at about 10% per year, then you multiply it out and you end up at about 11.4 megabits per second. So the machine that it's being installed on needs to be resourced correctly for 11.4 megabits per second right now so that you don't have to worry about expanding in the future. Maintenance and monitoring feeds. This is another interesting component that I think perhaps gets lost quite a bit. The monitoring feeds can or will likely be affected by devices being put in the network or taken out of the network. An example of this is perhaps with firewalls. If you have a tap between a core switch and a firewall, and you rip a firewall out, you put a new one in, what can happen is your tap can get orphaned if it wasn't included in the swap from firewall A to firewall B. So making sure that you have some degree of oversight into the monitoring feeds that are being fed into your packet broker is a good way to identify that, because if you go from a normal amount of traffic and then all of a sudden you drop off and you're losing everything, then obviously there's an issue with the monitoring feed. In terms of resiliency, again, this goes back to monitoring and feed health, not just with respect to the traffic you're feeding to the sensor, but the logs that are coming out of the sensor and the service itself. So how is it performing? Are you dashboarding the data? Are you doing something with it to make sure that if there is an issue with SuriCata that you can identify it quickly and rectify it? It goes without saying, failover and disaster recovery plans are a must. Failover in the context of perhaps you have a hot standby or you're load balancing and you have health checks set up for load balancing, something of that nature. A disaster recovery plan, in case SuriCata goes down, if you use it for like PCI DSS compliance, every moment you're down is every moment you're not compliant. So having a disaster recovery plan in place and being able to follow through with that plan in the event that something happens is absolutely necessary as well. So talking about management. This is everybody's favorite, right? Processes and RACIs. So some of the things that I thought maybe are more critical processes than others, and not to say that it's not supposed to be all-inclusive, but I feel like rule tuning, having a good analyst feedback loop is absolutely critical to being able to tune the system up properly. And what I mean by that is in the event that the engineer is not the same person who is performing the analysis of the alerts coming out of the platform, the analysts need to be able to provide feedback to the engineer so they can actually take action on what they're seeing. So without the feedback loop, it's practically impossible to tune properly. A periodic review of the rule set, just from the engineer standpoint, and we'll talk a little bit about this later with respect to dashboarding data, but being able to do a periodic review yourself of what the output looks like and say, you recognize that this particular signature is putting out way more alerts than everything else. It'd be really easy for you to proactively identify what's going on with that and correct it. Output from exercises, so like purple teaming. In the event that your purple team decides they want to work with you and then they identify maybe something that's not very well covered by some of the security controls in your environment, you would want to perform some degree of rule tuning based on the output of those exercises. So if maybe they're testing against a specific exploit and they identify that platform A, platform B, platform C found it, but SuriCata didn't, maybe taking the output of that and looking through the rule set to see, do I have the right rules on, Or perhaps maybe I can create a rule that is able to detect that activity is what you'd want to be doing. Change control, also everybody's specific, everybody's favorite. So in terms of like ServiceNow and that sort of thing, everybody's favorite platform, being able to have change control processes in place for how you do change control with your platform, being for regular maintenance or maybe even emergency changes is something that you'll want to have. And then down here at the very bottom is RACIs, so who's responsible, accountable, consulted, and informed for every one of these processes. Every process needs to have a matching RACI so that there is some responsibility in place for the folks who are supposed to perform those processes. So I think that scope of your deployment is really critical to determining the rest of what is happening down the pipe, essentially with tuning, but also with setting things up and what feeds you give to it, that sort of thing. The way I've always viewed this is that user stories make up your use cases, which then make up your functional scope. It's quite easy to kind of get lost in the details sometimes, or what will happen is you have 15 different people who have 15 different use cases, and it's hard to keep track of all of those. Identifying what they are, building them into use cases, and then creating a functional scope document that you can sort of check off those boxes on, or at least prioritize them, will assist you with determining what you've deployed SuriCata to do for you. So a couple examples there. If it's being used to close compliance gaps, obviously that's going to affect where you put your feeds in or where you're pulling feeds from. PCI DSS, as I keep going back to here, is a really great example of this. It's very specific. If you've ever looked at Rule 11.4 for PCI DSS, it's kind of ambiguous, but at the same time, it gives you a good place to start with respect to where you should start looking to pull your feeds from. Another really good point here is this supposed to be utilized to pursue policy infractions? The analyst that you work with, the output, if you're familiar with the emerging threats rule set, before 703 had a category called policy. If policy infractions are not necessarily in scope, then it's quite easy to figure out that you should turn that off. In terms of protected assets, this differs, again, from company to company. Sometimes it's everything, other times it's a very small subsection. It also determines how you're going to set up like address group variables and that sort of thing. So what's HomeNet? Is HomeNet the entire network, or is HomeNet just a small segment? That also determines what external is too. We also mentioned other teams' efforts already when we talk about purple teaming. Something else we see fairly commonly is the output from threat intelligence teams. So if your threat intelligence team brings a brand new threat intelligence to you and says, we need to guard against this particular threat actor that's doing this thing, it just ticked up, and it's going to be happening or has been happening for about a week now. And having a process in place to address that, and then also including that within your scope, is probably what you'd like to do. Getting into tuning, and we are racing through this. I'm only at 18 minutes. Sorry, guys. So tuning was it was hard for me to figure out where some of this stuff fit with respect to performing tuning at like the monitoring feeds or the rules or the logs. So what I did was I split out sort of general guidance. First and foremost, seek training. I understand that there's a lot of folks coming into this. Looking at rules can be awfully difficult if you don't know what you're looking at. There are a lot of really great courses out there. The OISF does some, and then there are plenty online, as well as blog posts and stuff of that nature as well. They're all helpful, especially learning from other people who have put posts up and said, I don't know why this is happening. That's practically how I learned most of what I know about rule tuning. The other part here is don't be too hesitant to make changes. Meanwhile, the analysts are dying under alerts, so they have extreme alert fatigue. I think that's fairly common in organizations today. it can be difficult because you think maybe if I turn an entire category off, that I'm going to lose out on this one signature that's going to be the golden signature that finds the one thing that you're really looking for, you really need to guard against. So it can be kind of difficult to convince yourself that you should be turning off potentially thousands of signatures, which is understandable. But at the same time, security is deployed in layers. So if your platform doesn't catch it because there's a small mistake in tuning, then there's the higher probability that platforms behind it will catch it. When you go to dashboard the alerts, I like to do contextual tiles, and then I like to do counts. So the example given up here, you have counts by SID, you've got counts by source and destination, you have counts by just source and just destination, and even below that, there are ones around ports. I feel like it's easy for you to pick out things that don't look right from a tuning perspective when it comes to high counts versus low counts. And the inverse of that is that your analysis dashboards are not your tuning dashboards. They're very purpose-driven. So identifying a good dashboard setup for tuning, and then also identifying a good dashboard setup for analysis is what you need to have in place for that. Sharing common terminology and definitions. So I'm not entirely sure if this is something that happens as prevalently as I think it does, but sometimes I encounter analysts that will say, X alert was a false positive. Was it really a false positive? If you go into detail with the analyst and you start asking the questions, you'll find that it was actually a true positive, but it was benign. So a great example of this is an analyst comes up and it says, okay, I have X alert for exploit activity, but the endpoint is already protected against this particular CVE for this exploit. Okay, that's fine. I think there's a bit of tuning effort that could happen there in order to help with that. And even while not necessarily turning the signature off, you can still derive value from the alert output from that particular signature, because was it supposed to be happening in the first place? Did it make it past the firewall? Where did it originate from? That would all sort of dictate if there's still value to the alert, even though there was no impact on the endpoint. So knowing what a false positive is and being able to at least have a conversation with your analyst about common terminology that's correct between the two teams is absolutely important here. So tuning monitoring feeds. This goes back up to what we were talking about for supporting platforms, packet brokers, and we'll also talk a little bit about Berkeley packet filters. Some of the common targets I see for filtration is vulnerability scanners, breach and attack simulation systems, and public Wi-Fi. I'm pretty sure that one came up in somebody else's talk earlier this week. The solutions for that, obviously being packet brokers, Berkeley packet filters. I think the preference would be actually the packet brokers, because even Berkeley packet filters consume CPU cycles. Some of the pros of this is that it offloads some of the processing impact from what would typically be consumed by SuriCata. And some of the cons, it can be difficult to work around tunneling and encapsulation protocols. If you have ever built a byte depth filter in BPF, you know what I'm talking about. The other thing is that on a shared resource system, such as SuriCata and Zeek, anything that's pre-processed is going to affect both of those. So it's a consideration to keep in place, or keep in mind that if you put something, if you filter something out at possibly the packet broker, it's going to affect both of those services. So tuning at process or tuning rules. I think the most common question that we get is what rules do I turn on or what rules do I turn off? It's always been my impression that you should follow the native organization methods that are provided with the rule set. So when it comes to the emerging threats, it's a great example of this. They have categories. Their files are actually split out if you pull down the zip by exploit.rules, info.rules, policy.rules, so on and so forth. And then on top of that, you have metadata, which, as we heard earlier, it can be inconsistent. Sometimes it's there, sometimes it isn't. Some of the approaches that I see to this, the most common one is default state. So you pull it down from the producer in its default state. There are rules that are turned on, there are rules that are turned off already. It can be quite noisy. Usually not the best option. I prefer actually categorical sprints. So if you have categories available to you, use categories. Create little sprints of maybe 3 or 4 different categories that you go through and you turn on and tune up. And then after that, you move on to your next sprint with another 3 or 4 categories. Lastly, cherry picking. So this is a good one for very, very precise picking of rules that you want to turn on. And I feel like, from the output of maybe purple teaming and that sort of thing, this is something that very much fits that. And it's not to say that you can only use one approach. In fact, I think I advocate for using bits and pieces from every one of these. Modifying rule logic. When we talk about modifying rule logic, there's a lot of things you can do with rules. But I think the most common things that I see people do with rules in order to make them work properly for their environment is modify source and destination IPs or ports, and then also performing negative matches within the content fields. And I think there's one signature that comes to mind very specifically for negative matching. That would be the Mozilla 5.0 signature from the emerging threats team. I think I put in 5 content negative matches before I eventually decided that the juice is not worth the squeeze. I should probably just turn it off. And then adjusting content using modifiers or sticky buffers. That's absolutely an approach you can do as well. I think there have been a couple of examples of this I've found over the years where you identify a rule that you could maybe hone in a little bit closer into what it's looking for by adjusting it and adding modifiers. We did talk a little bit about home net and external net earlier. Depending upon how you're deployed, you may want to adjust home net or external net. So if home net is defined very widely as everything that you have in your network when your scope was actually much smaller than that, adjusting those group variables to be more accurate is probably a good move. I feel like pass rules also very useful for shared resource systems when it comes to SuriCata and Zeek. Pass rules will affect SuriCata, it won't affect Zeek. Pros for this, you get very granular control out of rule tuning. You can positively affect the processing impact, and then inversely of that, if you do this not quite correct, you can negatively impact it as well. So post-process, we get into tuning of the logs. So these are things like the threshold.config file. You have threshold, rate filter, and suppression rules that you can put in place for those. And depending upon under what circumstances you're working in, I think a good example is if you don't actually administer the packet broker per se, and you can't put something in place right then, you can absolutely put in suppression rules for it. When it comes to global suppression rules for all rules based on IPs and CIDRs. When it comes to SIM and XDR specific capabilities, again, we get into filtering. So you can do a good bit of filtering on the SIM side. With that, the processing impact is already realized, but if you're a little bit limited on what you can do from the SuriCata side, that's another place that you can perform those activities. Also, from the SIM side, you can definitely create different buckets, and you can separate some of your alerts out based on, maybe things that are known good signatures versus ones that still need to be vetted. It is easy enough to create separate buckets or separate indexes, and then be able to search those properly, and then also, have hot or cold buckets you can look at in the future if you need to retroactively perform investigations. The pros of this is that it's easier to work around tunneling and encapsulation protocols. So when it comes to threshold, that actually looks at what's being produced in the logs as a source and destination, and SuriCata does a pretty good job of digging that out for you. And then on top of that, like we said before, you can separate logs by hot and cold buckets. The cons, processing impact is already realized, and then on top of that, your tuning can be less granular here than with rule tuning. And it looks like I raced through my presentation at exactly 30 minutes. So we have a lot of time for questions.
In your environments, do you typically have control over the packet broker? And then also as a follow-up, what are the primary packet brokers that you're seeing out there?
So a lot of the environments that I see, in environments I've worked in, I have had some degree of control over the packet broker, if not directly, indirectly. So I can always ask for filters to be added, that sort of thing. As for what we typically see, it's a good mix, actually. I would say, a lot of the main packet brokers you see out there, they're ones that you'll see in a lot of environments.
All right, thank you.
Hi, Adam. Lucas here. Can you expand a bit more on the hot and cold buckets? I didn't quite get it.
Sure. Yeah. So what I usually see is people who identify rules as known good rules, right? What they'll say is, this one has produced really high quality alerts in the past. So what I want to do is send that to a bucket where it gets processed much quicker, is easy to split out from the rest of your alerts. When it comes to cold buckets, there may be things that are less vetted. So if you encounter something for the first time, it's not that it shouldn't be looked at. It should definitely be looked at. But the value of those have not necessarily been realized yet, so it's easier for people to say, let's push it over to the side and deal with the things that we know work first versus the things that don't. And then with cold buckets, of course, you have the capability to retroactively go back and perform investigations in the past for maybe something that did fire that you didn't see. And this kind of goes back to a core issue that I see, is that if you have everything turned on from the start, you're pumping out alerts. You have millions upon millions per day, depending upon the environment that you're in. And there's no practical way to sort through that without just saying, okay, these are all good, known good, and these are, we don't really know yet, so we just put them in a cold bucket.
Okay, thanks. And is it something CM related, or would you set this kind of in, let's say, some rules, metadatas?
I'm sorry, say it again.
Would you set the division in hot and cold buckets somewhere in CM, or would you set it in rules?
You can do both, actually. Depending upon how you're exporting, you could set up multiple export destinations and maybe send just this stuff depending upon how it shows up in maybe syslog, for instance, right? And say if it has SID or whatever, that it goes here. If it has SID any other than that, it goes over here. And then on the SIM platform itself, I believe there are capabilities within those to do the same.
Okay, thanks.